Studio using a Windows XP installation. So if we start with this on our desktop, we have a directory called Graph, and inside Graph is where we've defined our project using CMake. The first directory here will contain a file cmakelist.txt that defines the first set of instructions that CMake will utilize. We take a quick look at this. It includes 3 commands. One is to make sure we're using a recent version of CMake to ensure our commands are compatible. Secondly, we're defining a project. In this case, we can name that project, and for this example, it will be called Graph Project. Finally, there'll be a third command, which is add subdirectory. This command will tell CMake to look inside the directory named src for further instructions. Inside our src directory, we have 2 things. We'll have the set of C and H files that we have for our project, along with an additional CMakeList.txt file. This CMakeList.txt file will define 3 things as well. The first one will be the commands we would like it to use while compiling our program. These are our C compilation flags. -W all indicates we'd like all warnings to be reported, and -G will enable debugging options. The next command will search for all .c and .h files within the current directory, and it's going to combine those and use those for the executable, which is defined in our next command here. So now we have add executable that defines a new executable called Graph. That's the name of our program that we would like to be able to run. All of our .c and .h files should be located in this src directory, and if we need to add more, we can add as many as necessary, and we need to do that before we run CMake. So Graph directory is our top level directory, which is what we want to provide as the input to CMake. So we're going to jump over to CMake here. So when CMake is looking for the source directory, it's looking for that top level directory that defines the first CMake list file. For us, we've located that on our desktop, and we've labeled it the Graph folder. Please note that it is not the folder called src that we need as the input here, but rather that top level directory Graph. We now need to create a folder that will create the build files in. Because we don't want to have a mix of build files and source files all in the same directory, we're going to create a separate directory to put all of our build files. So we're going to create a new directory here called build. And we can provide that as the input to the program to tell it where to build the file. Once we have this done, we can then click Configure. The Configure option in CMake will allow us to select the type of project we want to be able to create. Notice there are lots of projects. In this case, we're trying to generate a Visual Studio project. On my system, I have Visual Studio version 2010 installed, so I would choose Visual Studio 10. At this point, CMake is going to try to analyze the system to make sure that a working installation of Visual Studio has been installed. Once that's complete, we don't quite have our visual project generated yet. We have to then click the Generate command. As soon as we run this Generate command, if we now look inside the build directory, we should have what's called a Visual Studio solution. That solution has the name Graph Project. This comes from the name we specified in that first CMake list file. Let's go ahead and open it up. So within Visual Studio, there's a couple things we'd like to make sure are working correctly. First, we'd like to make sure the Solution Explorer is showing. If you don't see the Solution Explorer, you can enable it by going to View and selecting Solution Explorer. You'll see 3 things in there: All Build, Graph, and Zero Check. All Build and Zero Check are generated from CMake itself. Graph is the name of the executable we defined within our CMake list file, and if we expand that, we'll find the source files that we had listed inside the src directory. This is the command that we actually want to run. If you notice, all build in this case is bold. If we try to run or debug our program, it's going to try to run or debug all build by default. So a suggested command to utilize to make it more convenient is to set Graph as the startup project. So if we right-click on Graph, we can tell this to set as startup project, and now when we just simply click debug, it will by default run graph as our implementation. We can then directly edit our files within inside Visual Studio here. But when we run this, Visual Studio, when it debugs your program, will open your program up in a separate window. It'll run the program, and when it finishes running, it will terminate and that window will close. So if we have any output that's generated our program, we won't be able to see it. So in order to make it stop right at the point before it exits, within the main, we can look for all the return commands from the main, and we can set a breakpoint there. So in this case, we have a return 1 from our main function here. We can add a breakpoint right at this return. We can additionally add a breakpoint at each of the other returns that we find within our main program. And finally, here's our last one. Now that we have that, we can tell it to debug. You have a few options. You can go to debug and tell it to start debugging, or if you have your debugging toolbar, you can just click the start debugging option here. If your program hasn't been compiled yet, Visual Studio will go ahead and compile your program again if any files have changed since the last time it debugged. As you can see, now we've stopped here at this breakpoint, just after it printed the return statement. And if you look over here, you can find the console application that it opened up when it ran your program. And it's providing a usage statement indicating that we have not provided an input to that file. In other words, we haven't specified the command line arguments that our program should run. So let's go ahead and stop our debugging and look how to set that. If we go back to the Solution Explorer and we look at the graph option and right-click on that, the last option here will be Properties. Within Properties, we can look at the debugging options. And inside the debugging options, we'll see an entry called Command Arguments. So here we can type the command line arguments that specify the location of our input file. For example, we might have a file located directly on our C drive called graphinput.txt. If you notice, I put quotes around these arguments. Quotes are necessary if you have any spaces within your path of your file. Any spaces will be interpreted as individual command line arguments and will be broken up into separate ones, which is not what we want, so we recommend putting quotes around any command line arguments that represent file locations. Now if you click OK and run that, it's going to try to open up that C file that we specified on our command line argument, which case we'll then run our program using that as the input file.